Da, 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 da. Mr. K online. Warning, this experiment requires an adult.
Hi guys, and welcome to States of Matter. What is matter? Well, matter actually is all around us. Everything is made of matter, and matter is made of atoms. Now, if you're interested in atoms, go and look at one of my previous videos that's about atoms, and you'll find out more there. But anyway, let's get back to matter. Everything's made of matter. My hair's made of matter. This is made of matter. The orange juice is made of matter. Even the air is made of matter. So everything's made of matter, and it's anything that takes up some space. Now, there are three types of matter. The first one is a solid. The second type of matter is a liquid. And the third type of matter is gas. Let's get some examples of these. Okay, so a solid could be, example, a wall. In my laboratory, I have a wall. I hit it. Yeah, I can feel it's hard. It's there. Another example of, liquid could be water, okay? Or even this orange juice in front of me. Another example of matter, and in this case, gas, could be air. Or even smoke, okay? There's a little bit of smoke coming off this right now because I've got a hot plate here. Anyway, let's keep going. Okay, so today's experiment, as we talk about the states of matter, you will need the following things. You will need, number one, a cooker or a pan. Now I've got a little skillet here, whoa, and a little bit of gas just went by, or smoke, which is a form of gas. So you've got the cooker there, and I've got also the pan. Now that's getting quite hot, so be very careful, kids. If you're going to do this at home, okay, make sure you got a parent to help you because it can be very dangerous. I mean, you could use a cooker like this, or you could use some other type of cooker like your cooker in the kitchen, but get your parents to operate it, okay? Don't use it yourself. Awesome. So there you go. I've got a cooker there and a pan. The other thing that you'll need will be ice, which I've got here. There they are, my little bits of ice. And then also you'll need a plate. I've got a plate. Actually, I've got a couple. I've got one big plate and a little bit of a small plate there. Then also you'll need a freezer. I really couldn't lift that over here, so you're going to have to take my word that it's here. A freezer. You're also going to need a paper cup or a plastic cup, which I've got here, or a normal cup actually would even do, but we'll talk about that later on. You'll also need an icy pole stick, and you'll also need, after that, orange juice, which I've got here, okay? Instead of my icy pole stick also today, I'm going to be using a spoon, okay, as my icy pole stick, but yeah, you could do that as well. Okay. So let's keep moving. Now let's talk about solids. What is a solid? Well, a solid, are normally things that are hard, okay, and they don't change their shape when you touch them. An example could be a brick or a piece of ice. Now let's have a look at the table beside me. The table beside me really explains it in a lot more detail than just saying that it's hard and it doesn't change shape. It actually talks to you about particles, like the atoms. What are the atoms doing? Okay, so, well, the atoms, first of all, let's have a look at the diagram up the top here. The diagram up the top shows you how the atoms are sort of like arranged together. And you can see that with that there, they're really tightly packed together and they don't move. They haven't got that much room to move around each other. Okay, so there's no movement of the particles or the atoms. Also, they have low energy. There's not much energy in these atoms. We'll talk a little bit more about that later on. Also, they're very close together. They're packed in together, the atoms, so they can't move that much. And also, does it take the shape, if it's in a container, would it take the shape of that container? Well, no. If something was hard and you put it into a container, like example this spoon, it's hard. When I put it into this container, which in this case is a cup, it doesn't change its shape, does it? So, no, it doesn't change its shape when it's put into a container, or it doesn't take the shape of the container. And the final thing is that, can it be compressed? Can it be like squeezed and made smaller? Well, no, it can't, okay? It's always the same size because the same amount of atoms and they're all tightly packed in together. Now, let's go on to the next one. So, let's talk about liquids. Now, liquids, as you can see here, they are, you can feel them. They're a little bit softer. They do change shape when you touch them. Okay, and there's some examples of them here, which I've said are water and orange juice. And funny enough, I've got orange juice here. Oh, yum. It's delicious. I squeezed it just before. Anyway, so that's a liquid. Okay, now let's have a look at the table beside me and just talk about what's happening with the atoms. Well, as you can see from the diagram, the atoms are not that tightly packed in. There's a bit of space between them. They can move a little bit, yeah. They do have some energy, not like the solids where they don't have much energy. These atoms do have a lot of energy. Then apart from that, they are fairly close still, right? There's still a little bit more space than there was with the solids, but they are still fairly closely packed together, the atoms here. And then finally, the last couple of things. Does it take the shape of a container that it's put into? Well, yes. Look at this liquid. I put orange juice in here and it has taken the shape of the container. Can it be compressed more? No, it can't be compressed anymore. That means it can't be made smaller than it is. Okay, there we go. Now, the next form of matter that I wanted to talk about, which was gases. Now, gases, to be honest with you, these change their shape quite a lot, and sometimes they're so thin that you can't even feel them. Like example, I put my hand through the air. I really can't feel the air that well, but there are atoms there. But why can't I feel it? Well, the reason really lies in if you have a look at the diagram there of how the atoms are arranged, they're not very well packed in. There's a lot of space between the atoms. So when you're putting your hand through the air, it's actually going between the atoms, or it's pushing the atoms out of the way really easily. So gases can change their shape very easily. With gases, their atoms do move easily. They've all actually got high amounts of energy within the atoms or between the atoms. Also, the particles are not close together at all, as you can see from the diagram. They do, when they're in a container, they do take the shape of the container, gases. And then finally, can they be compressed? Well, yes, they can. And the reason they can be compressed is because they actually have a lot of space between the atoms, as you could see with the diagram here. Cool. Okay, so they can be made smaller. Interesting. Okay, so let's talk about today's experiment. Okay, so I've got this fry pan here, and I've got this cooker, and they're both very hot. Now I've got ice here, and ice, is it hard? Yes, it is. It is very hard. So when I push it, does it change shape? No, it doesn't change shape. So what is that? A liquid, solid, or a gas? What do you think? Okay, so if you said solid, you're correct. It's hard, it doesn't change shape. Okay, but how could I change this into one of the other states of matter? How could I change this into a liquid or maybe even a gas? Well, the way you can do it is simple. Do something like this. Oh, as you can see, I've put it now on the hot plate and it's hot. And funny enough, this solid, which is ice, has now turned into water. Okay, you can probably see that from there. I might put some more on. There we go. Now, when the ice gets hot, it turns into water. But then when the water gets super hot, it turns into gas, steam, which is a gas. So, steam, that's interesting because we've changed the temperature of the solid. It has turned into a liquid, being water, and then it's changed into steam, which is a gas, and it's all because of how hot we made it. Wow. That's interesting. So, let's keep going. Okay, so how do you change the states of matter? How do you change them from one state to another? Well, you can do that by changing its temperature. Okay, so by making something hotter or colder, you can change the states of matter. Okay, so you could say, example, you got something that's solid and you made it hotter, a little bit warmer. Okay, as you can see by the diagram here, it would basically turn into a liquid, and then the liquid, if you made that warmer, would turn into a gas. Okay, and I've got my example here that we've done today in our experiment. I've taken ice, I've made it a little bit warmer, which made it into water, and then I've made it hot, and it's made it into steam, which is a gas. So that's super cool, isn't it? Wow. I can't kind of see you here. I'm sort of like gorillas in the mist with all this hair on my head. Okay, so on to the next thing. Now you can actually make it go the other way. Now, how could you make it go the other way? Well, what you could do is change its temperature again. And the way you could do that is if you made the gas cold. And we're going to do a little bit of experiment where we're going to put a little bit more of the solids on top of the hot plate, which is, the ice on the hot plate, making them hot. And, they'll become super hot and then turn into a gas, which is steam. And then I'm going to capture the gas on this plate. Now, this plate's cold, so let's see what happens. Now, the gas is rising, being the steam, and it hits the plate, and the plate is cold. So it's making that gas cold again. Now, let's have a look and see what has happened here. Okay, something's happened. Oh, it's interesting, the gas is still going up. Well, the steam is still going up. So here we go. Oh, yeah, okay. So I don't know if you can see that there, but there are droplets of water where the steam has actually risen, hit the cold plate. Because the steam's got cold again, well, that gas has now turned back into a liquid, which is water. Now, if we wanted to take that one step further, we could basically take that to the freezer and freeze it. And actually, that's what we're going to do today. We're going to reverse this process of changing a gas back into a liquid and then back into a solid. Now, we've done that part where we've changed it back into a liquid, but I've got a liquid here, and I'm going to now change it back into a solid. So I'm going to take this, pour it into my cup. Now, this cup should be able to be put into the freezer. So there you go. I've done that now. Okay, it's ready to go. So I'm going to put that back in the freezer like that. And we're going to see if changing the temperature or making it super cold will actually change its state of matter. But I'm pretty sure you know the answer already, don't you? Anyway, you try this experiment as well. See how that goes. This one's pretty safe. You don't have to worry about this one. But please, be careful with the hot plate. Get mum and dad to help you out. Excellent. Thanks, guys, for watching. Have a great day and see you next time. Bye! Bam! It went back from the freezer. I took the orange juice, put it in the freezer, and I've just got it out now, and look what's happened. Oh! So it was a liquid previously, but now it's turned into a solid, something that's hard and doesn't change its shape, really. This is super interesting because obviously it's showing what we originally were saying, that, temperature changes the states of matter. But also it's interesting to note how much energy is also in the atoms. It's interesting to note that when you add heat to atoms or a group of atoms, they actually separate and move around more. Okay, so we saw that with the ice. When it was together, it was a solid and the atoms weren't moving around. They were closely compacted together. But then when we made it hotter, it turned into water, and obviously the atoms started spreading out and moving around each other. And then finally, when it was super hot, the water, it evaporated and actually turned into a gas, which was steam. And those atoms had lots of energy, and thus they separated from each other and spread around. Now, as you can see, this we did the other way. We took some energy out of it by making it colder. So what's happened is that the atoms have stopped moving around each other and have actually locked into each other to make a solid, which is, yeah, the ice block I've got here. Now, normally what you would do is you would try and pull it out, but I can't because it's stuck in there. So just as well, I kind of like brought some hot water here where I'm going to transfer some energy or make this have more energy, and the atoms have more energy, and thus they should melt and hopefully free the ice block from inside. So let's have a look and see if that happens. So this is hot water. Okay, so we'll put that in there, and hopefully I can get my ice block out. I hate something. So here we go. Oh yeah, this is looking good. Okay. Oh, aha! Hello. So the hot water actually heated up the outside of the ice block, turning the outside back to a liquid, and thus make it easy for me to pull it out because liquid actually changes its form when it's in a container, whereas a solid wouldn't. Okay, there's one more thing I wanted to kind of like discuss with you as well, is that different types of things have different temperatures that they melt or they freeze at and become a solid at. One such item that actually changes its states with different temperatures is a gas called methane. Now, you might know that gas as fart gas. Yeah, it's really interesting that actually it takes a lower temperature to freeze that. Now, if you went to the moon of Titan that goes around Saturn, you would find that there are actually lakes of methane there because the temperature is low enough to turn the methane gas back into a liquid. So you could go swimming in fart gas. Anyway, I hope you learned quite a lot about the changing states of matter. I'm going to go and enjoy the ice block. Thanks for watching. See you next time. Oh, yum. That's good. Bye. Thanks for watching one of my videos. If you've enjoyed the content or you just want to show your support, please just click the subscribe button down below. You hitting the subscribe button lets me know that you'd like to see more content from me. Thank you very much for watching, and I'll see you next time. Subscribe.